Okay, this is section 6.3 from trigonometry, where we're discussing the periodic nature of the functions that you're going to be studying, which are the trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. All the functions that were introduced in section 6.2. Okay, so starting off with graphs for each of those trig functions. Now, these are called periodic functions because the values of the functions repeat as you go around the circle and you continue to repeat your rotation around the circle. Certain values just repeat over and over and over again. Like, for instance, when you're at 0 degrees, the cosine value is 1. When you're at 360 degrees, you've rotated full revolution and you're right back at 0, but now it's called 360 degrees. The cosine is still equal to 1. So as you rotate over and over again to the same spot, you get the same values for the trig functions, and that's why these functions are called periodic. Now, these are graphs of these periodic functions. Rather than evaluating them, you're looking at a graph. So this is what the sine function looks like. Here's the cosine right next to it. Notice that they have the same shape. They just have different x and y intercepts. So, like, for instance, and when you look at this sine graph, they might ask you typical questions that they would ask you when you're looking at a graph is, what is the maximum value? This maxes out at +1 and it minimizes at -1. Okay, you're looking at the graph. Although this graph goes on and on and on in the positive direction as well as in the negative direction, you're looking at a piece of the graph that is shown between -2 pi and 2 pi. Notice that this has an x-intercept at 0. It also has x-intercepts at pi and 2 pi, at -pi and -2 pi. So every pi units, it is cutting into the graph having an x-intercept. So now, you will eventually be graphing these on your own. But now, just like kind of giving you a feel for what's the max, what's the min, what are the x-intercepts. They're going to ask you very few questions regarding the graphs. That's more in 6.4 and 6.5. So now this is the cosine graph. Notice that the x-intercept is shifted. And the y-intercept is different also. Notice that the x-intercept was 0 on this one. And here x-intercepts are 1/2 pi, 3/2 pi. The max is at 1. The min is at -1. It does not cut through 0, 0, so it doesn't have that same x-intercept. So this graph and this graph, when you compare them, really all that's happened is it has shifted. So like this point that you see right here, 0, 0, has now shifted on this graph. And all these are is these are horizontally translated. So when we talk about things like domain, you're trying to remember that domain really means the x values. Since this graph goes on and on and on, we say that the domain is all real numbers. It also goes on and on in this direction. It's just that they can only print so much of the graph to give you an idea of what the graph looks like. So the domain is said to be the set of all real numbers. The domain of the cosine function is the same. This also goes on and on in the positive direction as well as in the negative direction. As far as the range, when you're talking about the range means y values. Y values speak to the fact of how high and how low does the graph go. So when you want to talk about the range of the sine value, it goes as high as 1 and as low as -1. So it is said to be, this is how you write in between when you point to less than symbols. So sine is said to be between -1 and 1, and so is cosine. And that's just with regard to those graphs. Now you see here, that this is a picture of the tangent graph and the secant graph. And all the graphs that you see on this page, they actually have asymptotes. And if you remember from your MAC1105 class, asymptotes are places at which the function is undefined. If you do remember in section 6.2, we were evaluating these trig functions and finding their values at certain locations around the circle. And sometimes we would go to find the tan value or the secant value, as well as the cotangent and cosecant values, and they would just be undefined. Well, when you're drawing the diagrams or drawing the functions, rather than finding a value that represents a certain location, those undefined values that we were calculating in section 6.2, they are represented as asymptotes. And that's what you see here. So the asymptotes guide the diagram. They will affect what your domain is. Whereas on this page, where you have two graphs whose domain is your x values, whose domain goes on and on and on, being all real numbers. That's why these two pictures are together. And the range of -1 to 1. Now you're looking over here, and they're quite different. The domain is not all real numbers. You'll have to talk about the x values that are not included in the domain, which is at these asymptotes right here. And as far as the range is all real numbers, because this goes up to infinity. When they ask you what is the domain and the range of the graph, they're talking about these, blue figures. And you do also have to consider these asymptotes when talking about the domain. So the domain is listed for you here. The domain of the tangent functions, that's this right here, is all real numbers except where these asymptotes are. So your domain, which is your x values, this graph does go on and on and on in both directions. So we say it's all real numbers. Real numbers include positive and negative numbers, except notice where these asymptotes are so that you can say where the exceptions are in a concise manner. Notice that they're at 1/2 pi, 3/2 pi. Notice that on the other side, it's also at 1/2 pi, only the negative version. So you can see from the little portion that they have given you that these asymptotes always drop at odd multiples, in other words, of 1/2 pi. So this is 1, this is 3, this is -1. So these are called odd integer multiples of pi over 2. In other words, the denominator is always 2 and the tops are always odd integers. And that's when you're talking about the domain. You can say that it's all real numbers, meaning that it goes on in the right and the left direction, but that there are certain values at which it's undefined, which are represented by these asymptotes. And those asymptotes always occur at multiples of pi over 2, but odd multiples of pi over 2. Okay, as far as the range goes from negative infinity all the way to positive infinity. Looking at this secant graph on the right side of the page, if you were going to talk about the domain goes, this picture does go on and on, all the way to the right, all the way to the left, except you need to talk about where the asymptotes hit. So again, notice that the asymptotes are happening at, look, this is 1 pi, therefore that is 1/2 pi. If this is 2 pi, then this is 1.5 pi, also known as 3/2. 1.5 is the same thing as 3/2. So you have one at 3/2, you have one at 1/2. So and then same thing over here. This is 1/2. Only negative. So you see that the asymptotes for the secant graph are the same as this one. So when you want to talk about domain, you can say that it's all real numbers, and then you state the exceptions, which are at odd multiples of pi over 2, just like the tangent graph, which is why these two are grouped together. The domain is different though. excuse me, the range is different though. The range on this one, it goes on and on to positive infinity and on to negative infinity. So the range here is said to be from negative infinity to positive infinity. However, the range does not go all the way right through the origin to include all these values right here. See, what you're seeing here in red, just to help you understand this diagram, is just an auxiliary portion of the graph. It just holds up these blue portions that look like parabolas. So this is not really considered part of the graph. In fact, when I do teach you how to graph this by hand, I'm going to show you how to graph the cosine graph first. That's what you see in pink. And it will be the auxiliary portion that allows us to know how high these parabola looking portions are that open upward, and how big the downward portions are, like where the vertex of those portions open up. It'll just be at the max and the min of the cosine graph. Because cosine graph and sine graph are going to be the two graphs that we learn to graph first. And we can also get the secant graph and the cosecant graph just by knowing how to do sine and cosine. So it'll kind of be easy way to graph. So anyway, when you're talking about the range here, it is not negative infinity, positive infinity. Instead, it is, if you want to talk about how high it goes, it's all numbers greater than 1, because you're at a y value of 1 here. So this is everything greater than 1. That's all the upward parabolas. But then you also have to talk about all these downward parabolas that are part of the secant graph. And they exist at y values less than negative 1. Okay, so these upward parabolas have y values greater than or equal to 1 because they start at 1. And these downward parabolas have y values less than or equal to negative 1. In other words, they're underneath the negative 1 y value, which is what you see right here. Okay, then next we have the cotangent and the cosecant graph. The first 2 pages are just all, pictures of each of the graphs and everything, and reacquainting you with what domain and range is so that you can talk about these graphs. So what you're seeing right here is the cotangent graph. Notice that it is just like the tangent graph, only the tangent graph increases as it climbs to the right. This is called an increasing graph. When you're looking at a graph, you slide from left to right, and the y values are going up as you go to the right. That's called an increasing graph, whereas this one's called a decreasing graph. It goes in the opposite direction. When you slide left to right, the y values are falling. Anyway, and those are all MAC1105 concepts where there's a lot of graph theory discussed. So again, when you talk about domain, the domain is all real numbers except where the asymptotes fall. So you would say all real numbers except odd or integer multiples of pi. See how there's is asymptote at pi, then there's also one at negative pi. So these are not at 1/2 portions. These are at whole portions of pi. So we say that the exception, or in other words, where the asymptotes are, so that these are values that are not included in the domain, all real numbers except integer multiples of pi. So 1 pi, 2 pi, 3 pi. Those are integers. Integers also include negatives, so the asymptotes are also at negative 1 pi, negative 2 pi, negative 3 pi. But integers are not fractions. So these have asymptotes that are at fractional positions, namely odd multiples of pi over 2. And these have the asymptotes at integers. Okay, notice that the same thing is going on here. And if you want to talk about the range, it goes as low as negative infinity and as high as positive infinity, which is stated for you right here. Likewise, last graph, when you're looking at this, the domain is all real numbers except at integer multiples of pi. 1 pi, 2 pi, 3 pi. Likewise over here. Your range, as stated here, it is all values, these upward parabolas are all values greater than or equal to 1, whereas the upside down parabolas are all values less than or equal to -1. That's your range. I'll continue this discussion in the next